Hi students, today we are moving to part 3 of your lesson number 14, chemical effects of electric current. The first slide, the definition of electroplating is given. That is the first application we have learned in part 2 about the chemical effects of electric current. That the first application was electroplating. So what is meant by this electroplating method? This is one of the process giving a thin layer of desired metal over a metal object with the help of electric current. So, for doing this process, what you are supposed to do? You need one base metal like this, and you are giving a coating of another metal over the base metal. You have taken one base metal. The base metal will be a metal which is available at cheap rate. Over the cheap metal, you are giving a layer of costlier metal to give good appearance or to make it scratch free or to prevent corrosion or rusting process. So there are many advantages of doing this electroplating process. So you can decide which metal has to be electroplated over the base metal. What are the common metals used in electroplating? See the last sentence here. Chromium, tin, nickel, silver and gold, copper. So all these metals you can use for making a layer over this normal base metal. So we'll move to the next slide now. Points to remember while electroplating. What are the points you should remember for doing electroplating process? So whenever we are doing electroplating process, first you have to decide which electrode is your base metal, which electrode is your metal to be taken for giving the layer. So how can you decide that? So you are taking one container or anything electrolytic cell apparatus you're setting up now. You need one electrode, cathode and anode. So first one should be positive, second one should be negative. So first one should be anode. Why this is called as anode? Because the connection is given to the positive terminal of the battery. Next one is to the negative terminal of the battery. So you have to decide which is anode, which is cathode. So I will give you the proper diagram for better understanding. This is your experimental setup. For doing this electroplating process, I told you we need a base metal which has to be electroplated, and we need the metal which is used for giving the coating over the base metal. So which has to be taken as anode? The metal which you are going to give the layer, that has to be taken as anode. So always remember, anode is the metal which you are going to apply over the base metal. So you should not exchange these metals in different places. It should be proper. Anode should be the metal which is going to be placed over the base metal. So here you see cathode. What is cathode here? It is iron nail. So left side copper plate is taken as anode and right side an iron nail is taken as cathode. While exposing to atmospheric air, this air contains oxygen, right? So there is tendency for oxygen to come and attract over this iron and making a coating over iron. Iron plus oxygen. So iron, Whenever it is exposed directly to atmosphere, oxygen will be giving a type of corrosion. So you have heard about the word rusting, right? Some brown color deposit is formed over this iron, and this is called as rust formation or rusting or corrosion. So once this rusting starts, it will be eat away the metals. So to avoid that, what you can do before using this key, iron key from corrosion, give a coating of other metal which is not exposed to air. If it is exposed to air also, there is no chance of corrosion process. Like that, what one metal is selected here. What is the name of the metal? Copper. So you have taken copper plate as anode, which is connected to the positive terminal of the battery. Right side, what you have taken? You have taken an iron nail. So iron nail is taken as cathode. Now the experimental setup is ready by filling electrolyte. What is the electrolyte filled here? Copper sulfate solution. So copper sulfate solution, what is the color of copper sulfate solution? It is electric blue. Along with copper sulfate solution, we are adding 2 to 3 drops of diluted sulfuric acid. Why we are adding this diluted sulfuric acid? The reason is it will make the copper sulfate solution more conducting to electricity. That is the purpose of adding diluted sulfuric acid. Now the experimental setup is ready. The battery is connected to the copper wires and connected to the electrodes, and electrodes are immersed into the electrolyte. Now the current starts flowing, right? So you can see the reaction started. Then after some time, you can notice what are the changes happening during this chemical reaction. So first reaction happens inside the electrolyte, what we have filled here. What's the name of the electrolyte? CuSO4. Once electricity is passing through the electrolyte, this copper and sulfate are dissociated into cation and anion. So first the reaction happened in electrolyte. Copper and sulfate ions are separated. Once this is separated, cation, as it is positively charged, there is tendency to go to negative electrode cathode. So you can see this copper is giving a deposit or a layer of copper is formed around this iron nail. Not iron nail, here it is. You can use iron nail also for this reaction if you are not having this iron key. You can use iron nail or iron key for this. Then where does the sulfate go or move? It will be moving to the oppositely charged electrode, that is to anode. So Cu2 plus will be moving to cathode, SO4 will be moving to anode. From the electrolyte, again I'm repeating, first reaction happened inside the electrolyte, not from electrodes. Once this is initiated, then what is the secondary reaction here? You can see all the Cu2 plus ions dissociated from the electrolyte starts moving to different electrodes, depends on their charge. Then you can identify there is shortage of copper ions inside the electrolyte because all the copper ions are moving towards the cathode. There is shortage of copper cation. So for example, if you had 50 Cu2 plus inside the electrolyte, all the 50 started moving to copper. All the 50 are going to this cathode, that is iron key. There will be shortage of these copper ions. If there is shortage, there the reaction makes it very slow, finally stops. To avoid that, what happens in the secondary step? This anode, which is made up of copper, will start the reaction by donating its copper ions to the electrolyte. So first reaction is happening inside the electrolyte. When the shortage happens, that time this copper plate acting as anode will start giving its ions to electrolyte to balance the number of copper ions present inside the electrolyte. Like that, it is continuing. The reaction continues. Finally, the end of the reaction, what can you expect? Iron key is completely covered with this copper. So we can use it now after the reaction as it is free from corrosion. Once it is exposed to air also, as copper is exposed to air, there is no reaction happen here now. But iron, if it is exposed only, rusting happens. As iron is protected by a layer of copper, it is protected from corrosion or rusting. That is the application of this electroplating, in this case, copper plating. What are the uses of electroplating? I told you, whatever metals you are using as base can be exposed to air, can give rusting or corrosion. It is more exposed to air, chances of rusting or rust formation. We can prevent that. Second thing is, if we are using chromium metal for giving this coating over the cheaper metal, it can give shiny appearance. It can resist the scratch formation. Apart from the main advantage of resisting corrosion, the three advantages of giving this by the coating of chromium metal over all bathroom fittings, we can see this chromium metal and some vehicle parts. Second is, so iron if you use only for making some metallic products, what happens? Corrosion happens. So just give a coating of tin over this iron, which will resist this rusting process. Third one is coating of zinc. You know this process, galvanization. This process of giving a coating of zinc over iron is named as galvanization, which will help us to prevent the corrosion. And last one is gold, silver, jewelry making. In this, do you expect all the things what you are buying, the name of gold or silver, completely made up of gold or silver? No. There will be some content of other metals. You're not getting the complete gold or silver while buying the ornaments. There will be some metals are blended to give the stability or stable nature to the jewelry, because gold is a soft metal. It will bend always. So to give that hardness, we are blending with other metals. So that and all we are doing with the help of this electroplating process. So this application is more in chemistry, and this process is a costlier process also. It is not very cheap. So while doing this, as it is using electricity, you need more time to do, and it is expensive also. That is the reason you have to pay more for all the metals. So by this, we are winding up third part. So I have prepared part 1, part 2, part 3 according to the headings given in your textbook. Please go through all the PPT slides. Thank you.